Welcome to my channel. Today in this session, let us discuss about the second order control system. Already we have discussed about the first order control system. So let's discuss something about the second order system. And here we say the system as the second order as depending upon the higher order term in the numerator denominator of the transfer function. Here we have a higher order term as 2. So we are speaking the system as the second order system. Right? Let the system feedback be h of s. Okay. And hence the transfer function for the second order system may be for the provided g of s, we have the transfer function as k divided by s into ts plus 1 plus k. And from this transfer function, by writing this in the quadratic equation, we have k by t by s square plus t by s plus kt. We have obtained this by k divided by s square t plus s plus k. This is the function which we get equivalent to this. So to have a second order equation in this format, I have divided the function both numerator and denominator by t and have a transfer function as in this form. So this equation, the transfer function can be equivalent to that of this case. That means it can be written as omega n square by s square plus 2 zeta omega s plus omega n square. So this is the standard format of second order system, right? So by expressing this in this format, we get here omega n is said to be as the untimed natural frequency, and it can be written as root of k by t, which is equal to root of k by j. So tau, this is nothing but inertia, right? And zeta may be the damping ratio, and this is equivalent to 1 by 2 kt. So you are supposed to remember those formulas for further application. That is damping natural frequency, undamped natural frequency equation as omega n is equal to t. So this is obtained by, since we have the equation as omega n square by s square plus 2 zeta omega ns plus omega n square. This is our standard. When in omega n, this is equivalent to, we have the function as k by t. So omega n square, which is equal to k by t, omega n, which is equal to root of k by t. And similarly, for getting zeta, 2 zeta, which is equal to 2 zeta omega n, which is equal to, we have the function as 1 by t, and we already know the 1 by t, which is equal to root of k by t. So substitute here and bring the 2 omega n down. 1 by k into 2 omega n. Omega 2 omega n, which is equal to root of k by t. And by substituting this, we get the function as zeta, which is equal to 1 by 2. And the time response is determined by the characteristic equation of the second order system, right? And the characteristic equation of the second order system is given by s square plus 2 zeta omega ns plus omega n square, which is equal to 0. And this is the canonical form of the time response system for the provided second order function, right? So coming to the next case, the time response of the second order system can be analyzed as by the second order standard format in such a manner. This is the expression, denominator expression, quadratic expression, and this can be reduced by this. So this is written in this format as we have separating 2 zeta omega n as s plus zeta omega n square minus zeta square omega n square. So this is equivalent to the a square minus b square, which is equal to the 2ab, right? I am substituting the algebraic equation and I am obtaining the equation as s plus zeta omega n the whole square plus omega n. So omega n square, I am taking this from this two terms. I am taking omega n square as common, and which is equal to 1 minus zeta square. And I can able to write this equation as s plus zeta omega n the whole square. This is equal to d. This is nothing but the damped natural frequency. To get the damped natural frequency, I have taken the second order system of standard format. I have converted that quadratic equation in this form and I obtained the damped natural frequency in this manner, right? And the time response is nothing but this is the S domain function of the system. And for the time response, we need to have an inverse Laplace transform, right? So, in this, we have discussed the standard format of the second order system. The second order system format is generally in the case of omega n square by s square plus 2 zeta omega s. We also concluded that expression for omega n and expression for omega b, right? In addition to that, we have denoted that what is theta. So we use be thorough with those three expressions and this will be helpful for your objective case of preparation, right? So with this case, I stop here and in the further sessions, let us discuss the second order system with the various types of input signals and what about the response corresponding to this, the input signals which we have provided, right? If you like this video, like, share and subscribe.